I want to continue to look at some examples having to do with vectors and magnitudes and those kinds of things. So let's say that I had a vector that went from the point -1, 2 to the point 4, comma 8, something like that. Okay. If you want to write it in standard position, instead of starting out at the point -1, 2 and ending at the point 4, 8, we'd like it to start at the origin. Okay. It's always the same thing. You really want to know how much does my x coordinate change from this starting point here to that ending point there. And hopefully you can see there would be a change in x of 5 going from the -1 to the 4. So really all you have to do is you take the second x, you subtract the first x. Okay. 4 minus -1 will give you 5, okay? And then how far do you go from 2 to 8? That's a total difference of 6, okay? 8 minus 2 is 6, and our vector would be 5, comma 6. If I ask you to find the magnitude of that vector, of course, if you graphed it in standard position, it looks kind of like this. If we go to the point 5, 6, you could make a little right triangle that had a side length of 5 and a side length of 6. So if we wanted to find the magnitude, we could take the square root of 5 squared plus 6 squared. And let's see, that's 25 plus 36, that's 61. Radical 61 would be the magnitude there. And again, the symbol we would probably use for that would look like an absolute value symbol or maybe a double absolute value symbol. Okay, so that's some kind of a review of some basic ideas there. All right, some other things. If you have a vector written in standard position, maybe I would have something like vector v, you could call it something else, but let's say vector v is 3, -2, and let's say that vector u is the vector 2, 5. Okay, you can make calculations. You can add vectors just by adding the two x components together and then adding the two y components together. So if I wanted to find like v plus u, that would just be 3 plus 2 is 5. -2 plus 5 is 3. That'd be the vector 5, comma 3. If you subtracted the two, v minus u, you could take 3 minus 2, and that would be 1. You could take -2 minus 5, and that would be -7. Okay. You can also multiply a vector by a scalar. Okay. In other words, if I had vector v, and let's say vector v was the vector 2, comma 5, I can talk about finding 2 times vector v. And that would just be to take this entire vector and multiply it by a scalar. We're multiplying the whole vector by 2 in this particular case. And that basically just works like the distributive property. 2 times 2 is going to be 4. 2 times 5 is going to be 10. If you graphed it, it would actually dilate this. It would basically be in the same direction, but the magnitude would now be twice as long as the old magnitude. So I could ask you to add like 2v plus 3u. You'd take twice vector v, 3 times vector u. You'd add the two vectors together, that sort of thing. Okay, a couple of other things here. That's called scalar multiplication. There's also something called a unit vector. A unit vector is a vector that has a magnitude of exactly 1. Okay, let's say I had a vector -5, comma 12. Okay, the magnitude of that vector would be 12. Sorry, would be 13. It's a little 5, 12, 13 triangle. Okay, the unit vector, what I want to do is I want to dilate this thing down to be, instead of 13 units long, I want it to be 1 unit long. So I can actually just take 1/13 of that vector. And that would give me -5/13, 12/13. And that vector, if you put those numbers back in the Pythagorean theorem, you'll see that the vector has a magnitude of 1, but it'll actually be the same direction as the original vector. It'll just be shrunk down to be a shorter vector. So that's the idea of a unit vector.